This is 9.4, and we're going to be graphing lines and finding the solution. So there are three different sort of scenarios when you graph a line. Either you have two lines that are parallel, or you have two lines that intersect at a single point, or you have two lines that are actually two copies of the same line. So what does it mean to be a solution? Well, this right here is the point -4, -1. That is the only point that satisfies both equations. So if I put -4 in here, -2 times -4 is 8, and 8 minus 7, that doesn't actually work. Huh, that's interesting. So that is, oh, it's -3, sorry. -3 comma -1. That makes more sense. So if I plug -3 in there, I get 6 minus 7 is -1, and that's true. But if I plug -3 in there, the opposite of -3 is 3, and 3 minus 4 is -1, and it works. That is the only point that satisfies both equations. Each equation has an infinite number of points, but only one point satisfies both. Well, what point satisfies both of these equations? There isn't one. There is no x comma y that you can create that will work in both equations. And what point satisfies that? Well, this is infinite solutions, but that doesn't mean any point works. But any point on the line will work. For instance, if I tried 1 comma 1, is 1 equal to -2 times 1 plus 1? No, it doesn't work. But any point on the line would work. So that would be 0, 1. So is 1 equal to -2 times 0 plus 1? Yes. If I plugged it in there, is 0 plus 1 equal to 1? Yes. So when we answer this question, this system has no solution. This system has one solution, -3, -1. And this system has infinitely many solutions. So a lot of times we answer this by just writing the symbol for infinity. And remember, that does not mean that any point will work. It just means there are an infinite number of points that do work. So here we're going to graph -2 with a slope of 1, and then 4 with a slope of -1, and that is the solution 1 comma, or sorry, 3 comma 1. Easy enough. What is all that racket? Maria can choose plan A or plan B for her long distance charges. This question is so 1990. I don't even, how many of you actually have a home phone? Really? Wow. I have never paid for a home phone, ever. Um, so I don't even know how long distance works anymore. When I was a kid, if you called anywhere in Emery County, it was free, and maybe to Price. But if you wanted to call outside that area, you got charged for every minute. And in the 90s, there were these long distance phone wars, like kind of like the cell phone wars that they have these days, all sorts of deals. And I don't even know how long distance works anymore. Do you guys even know? Do your parents get mad if you call long distance on the home phone? No? I don't even know. So anyway, yeah, This is more when I was doing math in 1993 in Sanderfeld Junior High. This is the sort of question that we got. So, which plan is better? Well, it depends on how many minutes you use. If you use fewer than 250 minutes, you want to choose plan A. But if you talk for more than that, then you want to use plan B. So if Maria makes 300 minutes of long distance calls for the month, which plan costs less? So we go to 300. She wants plan B. How much less does it cost than the other plan? So the distance from here to here looks like $2. For what number of long distance minutes do the two plans cost the same? So that would be 250 minutes. And how much does it cost? That would be $20. Long distance calling. So passe. You used to, you guys are going to think this is weird. You could, if Emory Telecom charged too much for long distance calling, you could go buy a phone card. And the phone card, so let's say that Emory Telecom charged you 15 cents per minute. Well, you could buy a phone card that was 10 cents per minute. So you'd go to the mall or to the grocery store and you'd buy this card, and it would have a 1-800 number, which is toll free. And you would call 1-800 whatever, and then you would enter your PIN, and that would essentially log into your account. And then you would dial the phone number you wanted to call long distance, and it would connect you, and then it would charge you. So you'd buy a $20 card, and it would charge you 10 cents a minute for as long as that call was in session. And long distance rates went down and down and down and down. So when I went to college, I didn't have a cell phone to start out. So I had a phone in my dorm room, but I would just go buy calling cards at Walmart, and then I could call home for 5 cents a minute instead of, well, you couldn't even do long distance calling. Yeah, really complicated. Cell phones made our lives much easier. All right. So to graph this one, we start at 1 and we go down 1 over 2. And then the easiest way to graph an equation in standard form is to cover the x, and you get a y-intercept of -5, and then cover the y, and you get an x-intercept of -2.5, and then just figure out where those touch. Okay, so same thing here. You're going to graph two lines. The only problem is they're not going to touch in a nice place, so you're just going to have to guess. 1.2, comma 2.5. And Alex will give you a little bit of leeway. As long as you're close, or close enough, I guess, it should count. No. All right. Here we're going to use the Alex graphing calculator. So we go into y equals. We type in y equals. Go away. I'll have to do this from my computer. All right. So -2x minus 4. And then my second equation will be x minus 3. Then I push graph. And if I want to find the intersection, I pick one equation, y1, y2, and my guess point is right there. Find intersection, So negative 1/3 and negative 3 1/3. Okay. So in the mathematics world, if two graphs touch each other one time, then we call them consistent and independent. And it has a unique solution. So one intersection means it is consistent. If they touch, then the system is consistent. Independent means they only touch one time. Dependent means they touch an infinite number of times. And if they don't touch, they are inconsistent. So inconsistent, no solution. Consistent, dependent, and infinite solutions. So these two have answers, so they are consistent. This one does not have an answer, so it's inconsistent. A single intersection is independent, and it has a unique solution. Infinite solutions would be dependent. Okay. All right, Alex graphing. Okay. So I need to move this over and times by -1. So negative 0.6x. Oh. Negative 0.6x. And then it would be minus 1.03. Oh, you're right. Thank you. Okay. And then this one, we just need to divide by 0.1. So 3 divided by 0.1 minus 0.3 divided by 0.1, and x. That does not look right. 0.1. So 3 divided by 0.1 minus 0.3x divided by 0.1. And then we graph, and then we find the intersection of y1 and y2. My guess point is going to be right here. Find the intersection and round those. That's it. Get to work.